Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem longest repeating character replacement. Before we get into the problem, please subscribe to my channel. When you subscribe, it lets me know that you'd like me to make more of these videos. Okay, so we will start by reading this problem, and when we read through this problem, we're going to look for clues as to what coding pattern we can use to solve the problem. The problem says, you are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Alright, so looking at the example, the first example has 4 letters in the string, and they're A, B, A, B, with a K equal to 2. So the K says that we can replace at most 2 letters if we want to. So in this case, we would want to either replace the A's with the 4 B's, and then we'd have 4 B's, or we can replace the B's and make those B's be A's, and then we'd have 4 A's. Let's look at this other one. This other one has a K of 1. So one scenario, we could look at this window here, and we could see in this window that there is one B, and we can replace that B with an A since the K is 1, and that would give us 4 A's. So that would give us a longest sequence of A's to be length 4. Or we could go about it this way. We could look at that window. And in that window, we would see that there's one A. And if we replace that A to be a B, then we would have a sequence of 4 B's. Okay, so this is sounding like a sliding window problem, because we could create a window and look for how many times we can replace the smallest letter that shows up. And if it's under that K, then that would work. But let's look at a list that I made that lets us know what problems can be solved with sliding windows. So I made this list of different problems you can solve using the sliding window pattern. And if we look at this list, we can see that there's the longest sequence problem can be solved with it. That's what we're doing today. Today we have these letters in a string, and they want us to find the longest sequence of repeating characters. So we can use the sliding window problem. And when I was talking about that window, I was thinking out loud, and I was thinking, you know, what letter here shows up the least? And that's the B, right? Or I could also think about it like, what letter shows up the most? And that's the letter A. And what are some good ways that you can keep track of like the frequency count? Well, there's 2 different ways you could do it. You could either use like a hash map, where the key is the letter and the value is the frequency count, because you know it's going to be constant when you look up in the hash map, so that's good to keep track of the frequency like that. Or you can use an array if the constraints allow it. And when we look at a constraint like this tips us off that we can use an array. Why? Because this constraint says that the letters they're going to give us, or what I should say is the string that they're going to give us, it only consists of uppercase English letters. So we know there's 26 letters in the alphabet. We could just make an array that is of length 26 to represent those 26 letters. And then that array could be used to keep track of our counts. And that would be better than a hash map because the real world runtime on that would be faster than a hash map. When you look at the big O of the hash map and the big O of accessing an array, they both are constant. But when you think about how accessing a hash map works, you know that it's going to calculate, it's going to do a hash calculation to figure out where the index of the value that gets stored is placed inside the internal array that the hash map has. And that calculation takes a little bit of time. But when you are using an array, there is no calculation. It's a direct access. You tell it the index, and it reads it. So if you can, it's better to use the array. If this constraint wasn't here and they could give us Unicode, then we would use, in that case, we would go ahead and use a hash map. If we're going to have we don't want to have a gigantic, massive, huge array. We could just use a hash map instead. If we're not going to have like a small, if we're not going to have a small array that we can deal with. Okay, so let's get into solving this problem. So we're going to look at this conceptually here. Okay, so first off, we were talking about the counts, so let me talk about that. Okay, so what we could do is we could think about the ASCII character map. We know we're only doing uppercase English letters, so that's from A to Z. And when we look at that, we see the decimal value on the over here is 65 for A. So let's say if I read this A and I took A and just subtracted A off from that, then I would get 0, and that could be my index for my array. Let's say the next one I read from this list here when my window is expanding is B. So I read the letter B and I subtract off A. So I'm always going to subtract A off to convert it over to the index of my frequency count. So that'd be 1. So this one right here, this 0, this would keep track of my A counts. This will keep track of my B counts, C counts, all the way out to 25. 25 is going to keep track of my Z counts. Okay. All right. Now, let's get into this problem. So we're going to start with a window that is at location 0. And we're going to look at this window. We're going to read that A, subtract off A from it to convert it over to index 0, access our frequency counts array at index 0, increase it to 1. Now that we made an increase to this array, we're going to check to see if the value at that location is greater than, let me zero these out. These all start out 0 at the beginning. Is greater than the current maximum frequency count, and it is greater than the current frequency count. So I update that to 1 to match that. And so when we look at that, then we can say the reason why we're doing that is because we're going to want to see if we need to replace any letters in here. Let me explain why. So before we get deeper in this problem, let me just set up a window here like this big. Okay. So we can look at a window like that. You could look at that window and you could say, when we look at it the easiest way for us to think about it would be that if I can replace, one letter, what is the letter that shows up the least, and that's the B. And there's only one of those, so I could flip that B to an A. So if I flip that B to an A, then I would have 3 A's, and my max length so far would be 3. And then when I increase this, then I ask myself again, what letter shows up the least, and that's the B's, and are we able to flip that B to A? We are, because it says that our K is 1. When you're solving problems, sometimes it's easier to code your thinking if you do it the opposite. So the opposite logic sometimes is easier to code. So the opposite logic of what I just said would be, what letter shows up the most? So the letter that shows up the most is the A. Okay. And it becomes easier because we can do this. We can say, here's my window size. What is my window size? My window size in the orange is currently 4. So if I take my window size and I subtract off the letter that shows up the most, which we called, I'm going to have to make this window bigger here, max letter freq count. So if we take the window size and we subtract off the count of the letter that shows up the most, so that's going to be 3. 1, 2, 3. And we want to make sure that that is greater than or equal to K for this to be valid. So we have 4 and we subtract 3 off, and the result would be 1. So is 1, less than or equal to? Is 1 less than or equal to K? And it is. So because it is less than or equal to K, then this would work. And you can see this is going to be easier to program because I can just keep track of, my counts here, and I can check for a maximum. We're all starting at 0. And every time I update a count here, I can update my maximum, and then I can use this I could use this equation here to see if it's going to be valid from a window. Okay, so let's go solve it approaching it this way. So we're going to start all the way back here, and we're where we left off. So we left off like this, where we have a letter that's 1, that has a 1A, and we see it's a window size of 1, so 1 minus 1 is less than or equal to 1, so that works. So we update the max length to be 1. Then we're going to grow our window. Okay, so the next letter that entered the window was A, so we're going to say A minus A, which is 0, so we use that 0 to go to this index, increase this 1 to a 2, and then we're going to update the max letter frequency count to be 2 now. And then we're going to check to see if the window size, which is 2, minus the max letter frequency count, which is 2, is less than or equal to K. And it is, because this would be 0. So this would be 0 less than equal to 1. So because that is, then the max length gets updated to that current window size. Now we're going to increase our window again. And B just entered the window, so we say B minus A, index is 1. So we go to this index 1, we increment this to 1. We're going to update our maximum letter frequency count if this is greater than the current maximum letter frequency count, but it's not, so there's no update that happens there. We're going to check to see if our window size, which is 3, subtracted from max letter frequency count, which is 2, is less than or equal to k, and it is. So then we're going to update our max length to be 3. Now we're going to increase our window size. A entered the window. A minus A is 0. Going to 0. Increase this to 3. 3 is greater than max letter frequency count. Window size, which is 4, minus 3 is less than or equal to k. Because that's true, then we'll go ahead and increase this to 4. Okay. And then now we're going to increase this here. B entered the window. Okay, B minus A, index 1, go to index 1, which is 2. Okay, no update to the max letter frequency count. 5 minus 3 is 2. 2 is not less than or equal to k. Okay, so now we're in a situation where we have a window that is not valid. We know we can't increase our max length, but what do we do with this window now? Do we slide it? Do we shrink it? Well, we have too many. We need to shrink it because it's gonna, on the next loop it's going to increase, and we haven't yet found. We already found one at 4, right? And we're at 5 now. We don't want to go on to 6 because we need to see if there's like a 5 there. If we don't shrink it, we're just going on to 6, a window size of 6. So we're going to shrink it. Okay, how do we know when we need to shrink it? We need to shrink it when window size minus max letter frequency count is greater than k. Okay, so when we run to that scenario like we just did, then we shrink it. And A just left the window. A minus A is 0. Go to location 0. Subtract this by 1 because that A just left the window. Okay. And then notice something. I don't have to update my max letter frequency count. I'm going to explain why. First off, 3 represented that the maximum frequencies letter count of the A's was 3 that we found so far. And we just decremented how many A's are in the window now down to 2. So you'd think, wait, you need to update like your current maximum letter frequency count. But we don't. And that's going to simplify our programming by knowing that we don't have to do that. And I'm going to show why we don't have to do that. So the reason why we don't have to do that is because of this. We have already found the following to be true. A window size, oh, that's weird. A second. A window size of 4 worked, right? When we had 3, because we had 1, so that was good. Now, we just grew our window size to 5, and we know that a window size of 5 with a max frequency count of 3 does not work. It's 2. So the only way that it is going to work is if our max frequency count increases to 4. So when we run, and remember that whenever we make a change to this, like whenever we increase the counts here, that's when we check to see if the number that we increased it to is greater than the max letter frequency count variable. And if it is, then we'll update this. So this can just stick around because we already found out that we have a 4, and that's what we care about. We 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 recorded we have a 4. That's good. Now we're on to seeing if there's going to be a 5. The only way there's going to be a 5 is if we find a window where the max letter frequency count is 4, where there's 4, letters that are the same in our window. So if the problem was that, we needed to find a window that was smaller, then we would have to do that. But we need to find a bigger window. Okay, so now we're on to trying to find a bigger window. We're going to see if we can find one where we have a max letter frequency count of 4. So on our next loop iteration, we increase this, and that increases where B enters the window. So we go to B here, increase this to 3. Okay, 3 is not greater than 3, so that remains. And we're going to have this window here, which is 6 minus 3, which is greater than k. So we gotta reduce this window again. The a just left the window, and now this increases. The a just entered the window again. Okay. Okay. So there is no scenario in here where we have we can find a window of size 5. Let's back up real quick and see if we can create a scenario just for us to see how that would look. So let's see, we have 2 in here, we have 2 in here right now, let's say 2 in here. And then let's say that when we go to increase this here to include, oh, and currently we have 4, right? So let's say when we go here to increase this, this increases this to be 3. And let's pretend that our input here, we had a B here. Okay, so we would see in this scenario 1, 2, 3, 4, 5. 5 minus 3, which is 2, which is greater than k, so we got to shrink this window. And then this increases. B entered the window, 4. Okay, now 4 is greater than the max letter frequency count of 3, so we increase this. And then 1, 2, 3, 4, 5 window size, 5 minus 4 is less than or equal to k. So we found a scenario. 5 minus 4 equals 1. Good. So we found it. We would have found it now. Okay, so let us go look at the code and submit the solution and talk about it. Okay, so the first thing we said was that we're going to keep track of the counts with an array. So we'll have this array. I'm just going to call it freak for short, less typing. 26 to be the number of letters in the alphabet. Okay, and then now we're going to do our max frequency letter count. I'll just call it max freq. Actually, let me just call it what we called it, so that it's easier to see if you're taking notes. And then we have max length. Okay, and then now we'll do our sliding window. When you look at my code on my channel, I have a playlist that has all the sliding window problems that I'm making. And as time goes on, I'm going to add more sliding window problems, especially if you subscribe, because then I'll know that you want me to make more problems. What's really great about following on this playlist is that you'll see that my code is very similar between the different problems. And that's helpful because it's going to give you a template that you can memorize in your mind so that when you go to solve a sliding window problem, there's just like a few tweaks that you have to do. This helps you be able to remember how to go about solving a given problem. If you try to solve like a sliding window problem, like in very vastly different ways, it's just a lot of mental juggling that's unnecessary for you to do. Because there's a ton to keep track of in your mind, and it's just so much easier to organize it in your mind if you stick with similar code between the patterns. Just come up with your favorite coding style and template in your mind for each pattern, and then you use that to solve those pattern problems. It'll help you greatly to be able to remember how to um, write the code for the problems. Um, you don't want to just memorize writing the code, of course, because that's not going to help anything. It's about the understanding. Um, but with the organization of doing things very similar, it just helps you to be able to recall faster. Direct access array lookup in your mind, basically. Okay, so here we are. I have this window here where I'm starting out at 0, and I'm going to have the window end start out 0, 2 and go to the length. And then we talked about when I read from the array, I'm going to subtract off the A to convert it to my index. And then I'll use that index to look up in my frequency count array, and I'll increase the value. And then now after I increase the value, I'm going to update my max if I need to. So I'm going to take the max of what it currently is and do that with what I just increased. And then now I'm going to check to see if I need to shrink my window. So I have my window end minus my window start plus 1. I'm going to subtract off the maximum letter frequency count. And if that is greater than k, then now I need to shrink my window. So I'll read from that string, and then after I read from it, so I read from it, and then this happens next. After I read from it, then I move my window, I shrink it by 1, and what I'm going to do in my inside my count array is I'm going to decrement that count of the one that just left the window. And then now I'm going to take the max here. I'm going to say the max length of what I currently have with where the window is right now to see which one's greater. And whichever one's greater, I'll update it to that. And then after I finish all that whole loop, then I have my result. Okay, so we'll run that. See that passes those test cases, and we'll test it against all the test cases. That got accepted. Great. Okay, and then let's go look at the Python code. Python code. It's the exact same thing. I just, you know, used the Python syntax. So initialize an array that has 26 elements in it, starting out at 0. In Python, you have to say this, you have to use this function to get the decimal value of the character. So that's like that looks a little bit different than the Java. Okay, then everything else just looks very similar. And so then I'll run it. And I'll submit that. And then I'll check it, and we see that it passed. All right, great. Well, thanks for watching, and please go ahead and like and subscribe if you like this video and if you want me to make more videos, and I will see you guys later. Thank you.